trigonometry. Now, the first thing for us to understand trigonometry is we need to understand special angles, because all the operations that we work with in trig, in mathematics you don't use a calculator, so you're supposed to understand the special angles. The special angles we have is 30, 45, and 60. We also have those that are multiples of a 90, like 0, 90, 180, 273, 60. Those are also special angles, but we don't talk about those. Those you understand them from a graph. I'll mention something about them. So let's start with the 45 degrees special angle. 45 degrees. Now, for you to find the special angle for 45 degrees, what you use is known as an isosceles triangle. An isosceles triangle is a triangle that has got two sides the same, so even two angles are going to be the same. Okay, something like this. But for this isosceles triangle, one angle is 90. One thing that you need to know about isosceles, or for a triangle, it adds up to 180. So if one side is 90, it means that if we add the two angles that we don't know, they should add up to 90 also. So that 90 plus 90 should give you 180. But for this type of triangle, this isosceles triangle, we write two lines like this to mean that the angles are the sides are the same. So even the angles will be the same. So this one is going to be a 45 degrees. Even this one is going to be a 45 degrees. Okay, so I'm going to remove this one. Just know that it's a 45. Now for this angle, what you take is, you take it, these two sides which are equal to be 1 unit each. So if this is 1 unit, even this other side is a 1 unit, what will be the hypotenuse? So the hypotenuse is given by, remember the hypotenuse is the longest side, so it's given by what? You get the two sides, the opposite side to the angle, so this side is opposite to the angle. This side down is next. The word for next is adjacent, so that side is adjacent to the angle. So if you want to find this side which is missing, that x is found by you getting the square root of these two. You just get the small sides, you add them after squaring. Okay, so it will give you a 1. So I hope this is okay. You see, it's not something just to master, right? It's just something that you can know. So for an isosceles triangle, if you are dealing with a 45 degrees special angle, you take the two equal sides to be 1, while the hypotenuse to be 45. So therefore, if we start with a tan of 45, tan is given by opposite over adjacent. What are we using? There's something which we call SOHCAHTOA. So let me start with this, with sine, since I've written SOHCAHTOA here. So the first thing that you start with is the sine of the angle. So sine, the angle that we are dealing with here is a 45. So sine of 45 is going to be equal to opposite. So the opposite side to this 45 is this one. So that is a 1 over hypotenuse. The hypotenuse side, you can see that is a square root of 2. So that is sine 45. That's a special angle. Sine 45 is 1 over root 2. And then you also need to know cos 45. Now cos, you can see it is adjacent, and the adjacent side is also a 1 over the hypotenuse, which is also a root 2. So sine 45 and cos 45 is the same. You can even punch that on the calculator, you'll find. And then when you go to tan 45, now tan is given by opposite over adjacent. The opposite side is a 1, the adjacent side is a 1. So 1 over 1, that is a 1. Okay, so these are the special angles that we have to understand. Please, if you have got a question, be free to ask. All right, be free to ask. If we are okay up to here, can I see some reactions? Are we okay? If we are okay, let me just see people react to. All right, okay, good. Now, this sine, cos, and tan have got opposites. They have got their opposites or their reciprocals. The reciprocal for sine, we call it cosec. Cosec. You can see the way you remember them is the opposite for sine looks like cos. The opposite for cos looks like sine is sec. So you can see the opposite for cos looks like sine is sec. The opposite for sine looks like cos, cosec. So cosec of 45, you just reciprocate. If sine was opposite over hypotenuse, it means that cosec will be hypotenuse over opposite. So it will be root 2 over 1, which is just the root 2. And then sec of 45 is going to be also root 2. The opposite for tan is known as cot. It's a cotangent. So cot 45. So cot 45 is also going to be a 1 because you know the reciprocal for 1 is a 1 itself. Okay, so this is what you need to know about the 45-degree special angle. When we go to the other special angles, the 30 and the 45, 30 degrees, not 45 but 60, 30 degrees and 60 degrees. For these two guys, we use a triangle which we call isosceles. Now, for the isosceles triangle, not isosceles, but isosceles is the one I'm from talking about, which has got two equal sides. Here we use what we call an equilateral triangle. An equilateral triangle is a triangle that has got all the sides the same. All the sides are the same. So this side is the same as this side, which is the same as this side. For this triangle, you take each side to be 2 units. So this is going to be 2 units. This is going to be 2 units. This is going to be 2 units. And because of that, this triangle, each one of the sides, because all the sides are the same, even the angles will be the same. So 180 divided by 3, it will give you 60 degrees here. Even this guy is going to be 60 degrees. Even this guy is going to be 60 degrees. So what you do is that for this triangle, you now divide it on the very middle, there. I want to be, okay, straight on the middle. Why am I failing to draw something straight now? Okay, at least that. Where it is making a 90 degrees at this point. So after we do this, what are we going to see? So when you break this triangle on the very middle like that, what you are going to end up having is going to be something like, I'm going to just get one side, all right? I'm only picking one side. So this is a 90. And so what you are going to see for the other angles, this is still a 60 degrees. But remember this 60 on top we divided in two halves. So what has remained is a 30 degrees. Remember this side was a 2. And since this distance from at the bottom was 2, but we divided into two halves, so this is going to be a 1. So we can now find this side. Let's say it's a y. So for you to find any short side, all you do is you get the hypotenuse, which is the longest side, you square it, but you always subtract. Get the other one side, you square it, and then you square root. 2 squared is a 4, 1 squared is a 1. So 4 minus 1 is a 3. So this side is going to be square root of 3. So this is the triangle that we use when we are dealing with a 60 degrees and 45 degrees special angle. Let's start with 30 not 60 and 45, but 60 and 30. Let's start with a 30. If we say sine of 30 degrees, remember sine is opposite over hypotenuse. So to 30 degrees, opposite is 1. Hypotenuse is, you can see, 2. So therefore sine 30 is going to be 1 over 2. If we go to cos 30, cos is remember, so katoa, adjacent. So to 30 degrees, the side which is adjacent is this one. The hypotenuse is still a 2. So that is going to be the root of 3 over 2. And then when you go to tan of 30 degrees, that is going to be tan, remember, is opposite over adjacent. So the opposite side to 30 is a 1. The adjacent is a root 3. So that is going to be 1 over root 3. So these are the special angles for 30 degrees. If we wanted the opposites for these, for example, a secant, a cosecant, and a cotangent, you just swap these. So for example, the sec, sec 30, since sec is opposite for cos, sec 30 is going to be 2 over root 3, right? Just like that. If we go to 60, we have got sine of 60 degrees. Now sine is given by opposite. For 60 is this one. So you can see the opposite to 60 is root 3. The hypotenuse is still a 2. And then when we go to cosine of 60, cosine, remember, is adjacent over hypotenuse. The adjacent side is a 1 to 60. And then the hypotenuse is still a 2. And then for tan of 60, tan is opposite over adjacent. So to 60, the opposite side, you can see that is a root 3. The adjacent is a 1. So that will just be root 3 over 1, which is just root 3. Does that make sense, guys? Are we okay? Any reactions, please, if we are okay? Excellent. So having understood the special angles, another thing I want you to understand are triangles. Okay? Okay, not triangles, but types of angles. So I want to remind you about what you learned in high school. If you have got an angle that is straight, or let me start with an angle that is less than 90 degrees, you are going to be answering. We remind each other from what we did in high school. Okay? You can see this angle here. This is an angle. This is theta. So theta is less than 90 degrees. What do we call such an angle which is less than 90 degrees? Anyone? An angle that is less than 90. Okay, I didn't get an acute angle. Very good. So this is the acute. And then we'll be increasing the angles. So now we have got an angle that is exactly 90. Okay, theta is equal to 90 degrees. What do we call that angle which is exactly 90? The right angle. Excellent. Okay, right angle. And then we are going to increase it. Now we have got this angle. So this angle is between 90 and 180. What do we call such an angle that is between 90 and 180? Obtuse angle. Good. And then we are going to have exactly 180. So we have got exactly 180 now. What do we call this angle which is exactly 180? Okay, this is a straight angle. Good. Or a straight line. And then we have got an angle that is greater than. So we have got an angle that is here. You can see this one. So this angle theta, it's between 180 and 270. What do we call that angle? Anyone? So this is known as a reflex angle. And then you also have an angle like this one. This angle. So this angle is between 270 and 360. This is also known as a reflex angle. So in other words, any angle as long as it's between 180 and 360 is going to be a reflex angle. And then the last one, which we already did even earlier, so it's the one where I've got 0 degrees, okay, or 360 degrees. So we'll just put it. How do we even draw it? So we'll just do that. So for this one, theta is equal to 0 degrees, or it is 360 degrees. So this one is a circle, right? That's a circle. Now, one thing I want you to understand about these angles. So before we go further, is there anyone that's behind? Anyone with a question? Okay. So what I want you to understand about these angles is that the first angle, if the angle is less than 90, this angle is in the first quadrant. Okay? It is in the first quadrant. 90 degrees is between the first and second quadrant. Obtuse angle is in the second quadrant. And then the straight line is between the second and the third. Now for a reflex angle, it is either in the third quadrant or it can be in the fourth quadrant. That's what I need you to know. So let's talk about those quadrants. So we have got 4 quadrants like that, which you remember by all students or students take coffee. So what this means is that in the first quadrant, all angles here are positive. Whether we're talking about sin, tan, cos, they are all positive in the first quadrant. Okay, so the meaning is this: if I've got, let's say, sine, remember the angles in the first quadrant are acute. If I've got sine 30 is going to be positive, cos 30 is going to be positive, tan 30 is also going to be positive. But if I go to the second quadrant, let's say I talk about sine 150. Sine 150 is going to be positive, but cos 150 is not going to be positive, it's going to be negative. That is the same as tan 150. Why? 150 is in the second quadrant, so these other angles are going to be negative. Same if you pick an angle that is going to fall in any other quadrant. Depending with which quadrant you are, only that ratio in that quadrant is going to end up being positive. The other ratios are going to be negative. For example, 330 is in the fourth quadrant. So cos 330 is positive, while tan 330 and sin 330 will be negative. When you are doing your calculations on your, let's say they say find theta, if you punch on your calculator blah 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 tan inverse and then you find the value for theta. The angle that you find is normally in the first quadrant, all right? As long as the angle that you used is acute. When you want to find angles in the second quadrant, what you do is that you get 180 and then you remove the angle that you found in the first quadrant. Now let me use alpha. Alpha means acute. So because the angles that are in the first quadrant are acute angles, so if any acute angle that you find is in the first quadrant, what is an acute angle? Any angle between 0 and 90 is in the first quadrant. If you want to find an angle in the second quadrant, just say 180 minus that angle in the first quadrant. If you want to find an angle in the third quadrant, it's always 180 plus the angle in the second quadrant. If you want to find the angle in the third quadrant, it's 360. Sorry, in the fourth quadrant, it's 360 minus the acute angle. This is important for you to understand. What example can I give you here? Let's say they said, without using a calculator, without a calculator, let's say they say find, I'll just give one example. Okay, find, let's say, sine, what can I give? 315. Okay, sine 315. The way you are going to work out this one, first thing is you need to know in which quadrant you are. So just put simple sketch of a graph to see where 315 is going to fall. So which quadrant is 315 going to fall? Anyone? The fourth quadrant. Excellent. Okay, the fourth quadrant here. So this is 315. Now what you need to know is you always need to find the acute angle related to the angle that you've been given. What do I mean? So this is going to be the acute angle related to the angle that I've been given. Okay, so all you do is say 360 minus 315. What is it going to give us? A 45. So this is the angle that I'm interested in. So we'll come back and say sine of 315 is actually the same as sine. What is the angle that you have found? 45. But remember, in the fourth quadrant, sine, the only ratio that is positive is cos. So meaning that this is going to be negative. So attach a negative in front. The aim is to make sure that you find this angle. Why? Is because it's a special angle. That's the one that we know the value for. And now we'll say this is going to be equal to negative. Now remember, sine 45 is a special angle, and we said sine 45 is 1 over square root of 2. So this is how you find this one. Okay, I can give you another example. Let's say we gave you to say find the exact value of, say, cos. What can we give? Let's say cos 150 degrees. Again, you first just find where cos 350 is going, 150 is going to be found. Which quadrant is the 150? Okay, it's in the second quadrant, isn't it? So in case you are wondering how are we knowing these things. This is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. And then at 0, that's where we also have 3 schist. So 150 is between 90 and 180, so it is in the second quadrant. So it is here. This is the angle we've been given, 150. But remember again, you want to find the acute angle related to the angle that you have. The acute angle, if I say acute, it should always be related to these 4 lines. The positive x, the negative x, the positive y, the negative y. Okay, should always be related to those lines. So this is the angle here. So you need to find what that angle is. So all you do is 150 remove from 180. So this is a 30 degrees. And so you are going to tell yourself to say, okay, so this means that cos 150 degrees is actually equal to cos 30 degrees. But now in the second quadrant, only sin is positive. That means that this is going to be negative, so you attach a negative. So this will be negative. Now remember cos 30, a cosine of 30 is the square root of 3 over 2. How are you knowing that? We know already the special angles, okay? Already know the special angles. So I already derived them for you, so I can just get them from the brain, isn't it? So that is how you work out these guys. Is there any question before we proceed? Any question? Okay. Now, the last thing that I should just tell you before we answer some questions is how to convert between angles. Conversion. When you want to get an angle that is in degrees, you can take it to radians. Majority of the times you'll be working in radians instead of degrees. So if you have an angle in degrees, let's say for example 30 degrees, you can convert this one to radians by just multiplying by pi over 180. So that is going to give you a 0 cancel with a 0, 3 can go into 18 6 times. So this is pi over 6 radians. Okay. The opposite happens. Let's say if you have got 2 pi over 3 radians, you want to convert to degrees. Just say 2 pi over 3. Now multiply by the opposite. You multiply by 180 over pi. And this is going to give you the pi down. We'll cancel the pi on top. 3 can go into 18. 6 times 6 times 2. That's 12, isn't it? So that will be 120 degrees. If they say, what is 1.2 radians to degrees? Just get 1.2, multiply by 180 over pi. And whatsoever answer you are going to find is the answer, right? It's very easy. Have I lost anyone at any point? I need everyone to react if we are okay. Yes, Michelle? We are okay? Okay, just a moment. I can't really get you. You can say again? Okay, okay. You just pardon me. What? The voice solo. Okay, try to say again. Or converting. Okay. So on conversions, the only thing that you do is an angle that is in degrees, just multiply by pi over 1/8. The only thing that probably you have to know is you need to know that 180 degrees is the same as pi radians. Okay, just this. If you want, you can be using the conversion factor. 180 degrees is pi radians, so you can convert. Every time you are moving from degrees to radians, always multiply by pi over 180. Every time you are moving from radians to degrees, always multiply by 180 over pi. Is that okay? Excellent. Okay, let's do some practice questions. Now, I'm not telling you about identities today. We'll do identities in the next class. Given that sin theta is negative 3 over 5 and tan alpha is 3 over 4, where theta is a third quadrant angle and alpha is an acute angle, we want to find these operations here. Okay. So the first thing first, you need to be able to see where these guys are. So try to write the quadrants. So you have been told that theta is in the third quadrant. Where is the third quadrant? It's here. Okay. Now I should tell you that the angles are always related to the x-axis. If you are in the third quadrant, the angle you are dealing with is this one. If you are in the second quadrant, the angle you are dealing with is this one. If you are in the first quadrant, the angle is this one. If you are in the fourth quadrant, this one. So the angle is always related to the x-axis, not this, because this is related to the y-axis, right? So that's what you need to know. So for this one, for sine is the one that contains theta, so meaning that this is theta. Now remember, when you are finding sine, sine is given by what? Opposite over hypotenuse. So it means that this 3 is the opposite side. The hypotenuse is a 5. So you need to know that hypotenuse is always positive. Why is hypotenuse always positive? Because for you to find the hypotenuse side, you always square the two smaller sides. So that negative that you can see is actually from the 3. And then since you know the opposite side and the hypotenuse, you can find the adjacent side. And how do you find the adjacent? Anyone? How can we find the adjacent? Very good. The Pythagoras theorem, right? So it will be 5 squared minus negative 3 squared. Please put the 3 in brackets. If you don't put it, you confuse everything. So this will give us a 4. Okay? But even if it will give you a 4, a positive 4, you know that it's going to be a negative. How do I know that it's going to be a negative? We are along the negative x-axis. Along the negative x-axis, all values of x should be negative. Just like this was the negative y-axis. That's why this value is negative. Okay? That's why you need to know which quadrant you are dealing with, because by you using a Pythagoras theorem, you will not know that the 4 is negative or positive. And then we go now to the other angle. The other angle alpha is in the first quadrant. So we'll put it there. And you know this is tan, and you know that tan is opposite over adjacent. So meaning that the 3 is the opposite, 4 is the adjacent. If we want to find the hypotenuse, all you do is get these two guys, you square, you add them, and then you square root. 4 squared is 16, 3 squared is a 9. If you add them, is 25. Square root of 25 is a 5. So that's a side. Now, after you have done that, you can now answer the questions. We want to find sin alpha, cos alpha, sin alpha. Let's start with sin alpha. Now remember alpha, the angle alpha is the one in the first quadrant. Sin is opposite over hypotenuse. Opposite is a 3, hypotenuse is a 5. Okay. The next one we want to find is cos theta. Cos is given by adjacent over hypotenuse. But here we're dealing with theta, the one in the third quadrant. The adjacent side to theta is negative 4. The hypotenuse is a 5. Then the next one we want to find is cos alpha. Adjacent over hypotenuse. The adjacent to alpha is a 4. Hypotenuse is a 5. Have I lost anyone? Anyone who is behind? React if we are okay. Okay, very good. And then we can now do the next one. We want to find sin. I said we are not doing special angles today, but for this one, there's no way we can find it without special angles. If you have got sin and then two angles are adding, you need to just know the identity. This means sin, you get a first angle. Okay, I want to write it down so that I can have space to write the next one. So we need to know that sin or theta plus alpha, it means you get sin, you get a first angle, which is theta, and then you get cos, you get the second angle, which is alpha. If there is a plus here, also put a plus. If there was a minus, you also put a minus. And then you again get sin, but for the second time, you get a second angle. Again get cos, but now get the first angle. Okay, so that's the meaning of sin alpha plus theta, or sin theta plus alpha. It means sin theta cos alpha plus sin alpha cos theta. So now we substitute. What is sin theta? Remember, sin theta is given there. It's negative 3 out of 5. And then cos alpha, it's here 4 over 5. And then we say plus. Sin alpha is the one we found there. It's 3 over 5. And then cos theta is negative 4 over 5. So this will give us negative 3 times 4, that will be negative 12 over 5 times 5 is a 25, plus 3 times negative 4, that will be negative 12 over 25. So if you add negative 12 minus 12, because the denominators are the same, so just add what's on top. So that will be negative 24 over 25. Okay, so that's the answer there. And then for the last one here, we want to find tan of theta minus alpha. Again, this one is an identity. You just have to know, right? But we'll discuss the identities in the next class. But when you've got tan of theta minus alpha, it's always tan. Okay, you get a first angle theta, and then you are going to get the sine there minus tan. Now you get a second angle, and then in the denominator you say over 1 plus tan. You get the first angle, and then again tan, you get a second angle. Okay, so you take it like that. And then you now just get to substitute at these points where there is tan theta. You already know what tan theta is. Where there is tan alpha, just like that. Should I proceed or you can finish? I want us to do that when we discuss the angles. Is that okay? I mean, when we discuss the the identities. Okay, I hope that's okay. I hope we can go on with that one. Okay. So please, you just need to know this. So if there was if there was a plus here, what you do is you put a plus here, and then you just come and change a minus here. Now let me just write it down. Okay. So remember tan theta is given in the, okay, we didn't find tan theta, isn't we? Didn't. So tan is opposite over adjacent. The opposite is negative 3, the adjacent is negative 4. Negative 3 over negative 4 is just 3 over 4. And then minus tan alpha, Tan alpha is already given there. It is a 3 over 4. And then now we divide by 1 plus tan, remember theta, or tan theta again is negative 3 over 4. Tan alpha is 3 over 4. Now, because on top it will give us a 0, 3 over 4 minus 3 over 4. So 0 over anything, the answer is 0. So that will be the answer there. Can I see reactions if we are okay? Are we okay? Why is it that some people are not reacting? Are people sleeping? Okay. So the next question is saying, okay, this one again, use the result that cosec minus cot is tan 1 over 2. We'll discuss this one when we talk about special angles again. This is identities, we'll discuss it. Oh, I meant identities, not special angles. So if cos alpha is negative 3 over 5, tan beta is 5 over 12, where alpha is in the third quadrant and beta is acute. So let's again show this one. We've been told that alpha is in the third quadrant. So it's going to be here. This is where alpha is. Beta is acute. So beta is here. But what have we been told? We know that cos alpha is negative 3 over 5. And cos, is adjacent over hypotenuse. So the adjacent is this side. The hypotenuse is going to be this side. Okay. But remember, it's negative. And I said that the side that is always hypotenuse is never negative. So we need to find this missing side by using the Pythagoras theorem. It will be 5 squared minus negative 3 squared, which will give you a 4. But again, attach a negative. Why am I attaching a negative? Because it's the negative y-axis. All y values are negative. For beta, tan, they gave us tan beta, and tan is opposite. So the opposite side will be 5 over adjacent. Adjacent will be 12. So 12 squared is 144. 144 plus 5 squared, which is a 25. So it's going to give us 169. The root of 169 is a 13. So this is going to be a 13. So the next question we have is cos. Now we can find cos alpha plus beta. Again, this is only identities. We'll understand more when you talk about identities, but you just need to know that cos of alpha plus beta, what you do is, for cos identity, you always get cos, you get the first angle, but again get cos, you get the second angle. For sin, we get cos, you get sin, the first angle, and then you change to cos, the second angle, and then you get plus, you get again sin, you take now the second angle, and then cos, the first angle. But for cos, you get cos, the first angle, and then cos, the second angle. You change the sign. If it was minus, it becomes plus. If it was plus, it becomes minus. And then now you go to, you write sin, you get the first angle, and then again you write sin, you write the second angle. Okay? So this is how you expand the cos when two angles are adding. So what is cos alpha? Cos alpha is negative 3 over 5. How about cos beta? So we go here, cos of beta. Beta is given, cos is given by adjacent, which is 12, over hypotenuse, which is a 13. So that is 12 over 13. Then minus sin alpha. So let's find what is sin alpha. Sin alpha is opposite over hypotenuse, so that will be negative 4 over 5. And then sin beta. So sin again, for the one with beta, is opposite. The opposite side is a 5. Hypotenuse is a 13. So that is 5 over 13. So let's multiply negative 3 times 12. That is a negative 36. 5 by 13. 5 by 3 is 15. 5 remainder 1. 5 times 1. So that is a 65. And then we have got this negative and this negative inside will give us a positive. So 4 times 5, that is a 20. 5 times 13, that is a 65. Since the denominator is the same, just add the numerators. Negative 36 plus 20. That will just be a negative 16 over 65. So that is the answer. Are we okay? Reactions if we are okay. If you're not okay, just open your mic. Okay, very good. This is an identity. We'll do it in the next discussion. Even this one, even this. And then we have got this. They are saying given that A is 4 over 5, cos B is that where A is. So let's go. Cos A, and they've said that A is obtuse. Remember A, if an angle is obtuse, it means that it's in which quadrant? Anyone? It's in which quadrant? Very good. Second quadrant. So this is where A is. And B is an acute angle. If it's an acute angle, which quadrant is it? Excellent. Excellent. So B is in the first quadrant. So for sine A, it was 4 over 5. And you know sine is opposite over hypotenuse. It means that this other side, which we don't know, is going to be A3. 5 squared, 25. 4 squared, 16. 5 minus 16. 25 minus 16 is a 9. Root of 9 is a 3. But for this guy, attach a negative. Okay, why have I attached a negative? Because it's a negative x-axis. And then for B, cos. Cos is given by adjacent. So this is the adjacent 12 over hypotenuse, which is 13. So the missing side here, 13 squared is what? 169. 12 squared, 144. So that gives us what? 25. Square root of 25 is a 5. So that's the missing side. So we can now find what they are looking for. And what they are looking for is tan of A plus B. And we said that for tan, if you are adding, you get tan the first angle, put the same sign that is there, and then tan the second angle. Always divide by 1 minus tan the first angle, tan the second angle. Okay? So here we need to find tan of everything. So what is tan A? Tan is opposite over adjacent. So 4 over negative 3, which is negative 4 over 3. And then tan of B, also opposite over adjacent. That is 5 over 12. So that is going to give us tan A is negative 4 over 3 plus tan B is 5 over 12. Divide that by 1 minus tan A, negative 4 over 3, tan B is 5 over 12. So this will give us now negative 4 over, look at this. What we are trying to add is negative 4 over 3 plus 5 over 12. The way you easily add fractions is make the denominator the same. How can I make 3 12? I multiply by 4, but also multiply on top by 4. Why? 4 over 4 is a 1. So if I multiply anything by 1, the answer is itself. So I have not changed the fraction. I'm just trying to make the denominator the same. Now on top, 4 times negative 4 is negative 16. So since the denominators are the same, just add the numerators. So negative 16 plus 5, that will be negative 11, isn't it? In the denominator, we are going to have 1 minus Negative 4 times 5 is going to be a 20. So this will be positive 20 because of the two negatives. 3 by 12, that will be a 36. Now again, 1 plus 20 over 36. 1 is the same as 36 over 36. Why have I done that? To make the denominators the same. So now just add the 36 plus 20, which is a 56 over 36. 56 over 36. So I'm going to bring it here. So I've got negative 11 over 56 over 36, which is the same as negative 11 divided by 56 over 36. But if we change it to times, the 36 will go on top, 56 will come down. Okay. So please complete that. You put the answer there. So that's what you go about that one. I hope that's okay. Yes. Okay. Yeah. I'm also surprised. So that please don't forget that, isn't it? Okay. So that was on top. We're supposed to have negative 11 over 12. So this is negative 11 over 12. All right. So even this one is a 12 here. So just make sure that you do that. So you can actually do this. 12 can go here, it can go there, that will be 3 times. And then 3 times negative 11, that will be negative 33 over 56. Okay, and then we can work out this one. So cos arc sine root of 3 over 2 is equal to x plus root 2. Now what you need to know, guys, is when you have got sine of, let's say, remember we said that sine of 30 is 1 over 2. If you take sine the other side, it will become sine inverse of 1 over 2. Okay. So if you take sine inverse of 1 over 2, it will give you a 30. Hope you get that, alright? Is that okay? Okay. Sorry for that. So sine inverse of 1 over 2 is a 30, right? Now, the same thing I want you to understand is if you see sine inverse, it's the same as arc. Arc means inverse. So this is the same as arc sine of 1 over 2. That is a 30. Okay, no magic there. That's the meaning. Arc means sine inverse. So we'll go about with this guy here. So we have got cos arc sine. Okay, remember arc sine of root of 3 over 2 is the same as sine inverse of root of 3 over 2. But guys, I told you special angles. We said that sine of root 3 over 2 is a 60. So sine inverse of root 3 over 2 is going to be a 60. Sorry, I said that sine of 60 is root 3 over 2. So sine inverse of root 3 over 2 is going to be a 60. All right? So this means that this is going to be what? This is going to be cos, where there is arc, sine of root 3 over 2, or put a 60 there. And this should be equal to x plus root of 2. And you know that cos of 60 is 1 over 2 as a special angle. So this is going to be equal to x plus root of 2. Take root of 2 the other side. So we're going to have x is equal to 1 over 2 minus root of 2. And again, I told you, if you want to make your work easy, make the denominators the same. But for this one, we can just say over 1 is because the numbers are small. Get the 1 on top, multiply with the 1 down, that will give you 1. Get the 2 down, multiply with the 2 root 2 on top, that will be 2 root 2. And then multiply the two denominators, that will be 2. So this is the answer, right? Is that okay? Mm-hmm. Okay. Okay. So we said, remember from our special angles, when you have got sine 60 as a special angle, sine 60 is equal to root 3 over 2. So if I take sine the other side of the equation, it will become sine inverse, right? It's like the way we say, if you take 2, it becomes negative 2. So it means that 60 will remain alone. And then you are going to have sine inverse of root 3 over 2. So that tells you that root 3 over 2, sine inverse of root 3 over 2 is what? A 60. But sine inverse, you need to know that sine inverse is the same as arc sine. Okay? Where you have got inverse, it's the same as just saying arc. Arc sine is sine inverse. Arc tan is tan inverse. Arc cos is cos inverse. So that's why where there was arc sine of root 3 over 2, we had substituted the 60 there. Does that make sense? All right. Good, good. Is there anyone else with a question? Any other question? Okay. So these ones we'll do when we prove. Okay, so that's where we end. In the next class, we'll talk about identities and then we'll talk about sketching of trigonometric functions.